Callan here to help you with more Chapter 15, Lesson 10. Today, distance between 2 points on the coordinate plane. I'm going to go ahead, whatever the assignment number was, pause, take a look at your answers, and come on back when you are ready. Second page a little tougher. You had to draw your own models. Rewind if you need. For today, we're going to continue with our skills using the Pythagorean theorem, also understanding that roots might be irrational roots. They might not make a perfect integer. We're going to use those skills to find the distance between 2 points on a coordinate plane. And I'm going to show you a little Algebra 1 as well to get you ready. No matter what the date, no matter what the assignment number, go ahead and pause your video. Come on back when you're ready. It is a worksheet, ladies and gents. You can either receive that paper copy in class or use Kami. And let's pause and just read through the top part, or you can read along with me. On the map, each unit represents 45 miles. Now, West Point, New York is located at the point 1.5, 2, and Annapolis, Maryland is located at -1.5, -1.5. Question, what is the approximate distance between those two cities? If those cities do not sound familiar, West Point is the home of the College Academy for the Army. Meanwhile, Annapolis is the home of the Naval Academy. So if those didn't sound familiar, that's the reason why those cities were picked. Now, I'm going to show you two different methods. Method 1 is simply going to use the Pythagorean theorem, which we know that if we square each leg and add them together, it equals the square of the hypotenuse. So I'm going to have to look a little closer at the graph here. And I'm going to notice that the vertical goes 1 and 2 and 3 and 3.5. Meanwhile, the horizontal is apparently stuck in the middle. So 1, 2, 3. Even though it's in the middle, it's actually an integer quantity. So I can use the coordinate plane to find each leg, which in this case is going to be 3.5 and 3. I can take each of those numbers and substitute them in. 3 squared is 9, 3.5 squared is, actually I don't know what 3.5 squared is, but I do know the calculator will be an appropriate tool to add these two numbers together to get 21 and 25 hundredths. However, that's still the square of C. So to get rid of add, we subtract. To get rid of multiply, we divide. To get rid of a square power, we take the square or the second root. Now, most people don't write the two, but I do. A square power and a square root are inverse operations. Oh, good. And while it is possible to have two numbers to be a solution to this, it doesn't make sense to have a negative quantity as a distance. So answer there is going to be 4 6/10 units. However, I would like to show you another method called the distance formula. Now, the distance formula between 2 points is as follows. D equals the square root of, parentheses, x2, well that just means x from the second value, x from the second point, minus x from the first point. Then take those, whatever the difference is, and square it. Then we're going to do the same thing with the y coordinates. Subtract the y from the second point minus the y from the first point. Whatever that difference is, square it, and then add it up. And I want you to look, just to see a little of where this comes from, I want you to look at those two things. What do you see in common? Well, they both have a plus in between two squares. They also eventually will both need a square root. So there's more in common than you think. But I'm going to go through this very quickly, and you can look up on the internet other videos how to use the distance formula. The first thing I'm going to do is I'm going to take a look back at the points. This is going to get a little small, But if I'm going to look at this, I want to imagine the first point. Oh, it's right here. I can make it bigger then. The first point is 1.5, 2. The second point is -1.5, -1.5. And so let's go ahead and start substituting those numbers in. Some of you might even like to write it directly above and below, or below, and that's fine. So the x value from the second point, -1.5. The x value from the first point, 1.5, positive. And we're going to subtract those together. -1.5 minus 1.5 goes deeper down to get an answer, a difference of -3. Now let's take a look at the y-coordinates. The y-coordinate from the second point is -1.5 as well. Weird. Okay, the y-coordinate, there we go, something that's not 1.5. If I go down 1.5 and then go down further by 2, that's going to be -3.5. Now, some people at this point get a little nervous and say, how do we have negative lengths? Well, don't worry about it, because as soon as you take the square power of anything, a positive times a positive is a positive. A negative times a negative is also a positive. So that square power eliminates the concern about those negative symbols. Add them up, 21 and 2500, take the square root. Oh, look, it's the same thing. Now there's only one piece of the puzzle left. You can't say those two colleges are 4 6/10 units away. Remember, please, that each unit on the map represents 45 miles. So we're going to take that 4 6/10 and multiply it by 45, and therefore the actual distance as the crow flies, not according to roads or highways, but the actual distance between those two cities is going to be about 207 miles apart. Now, if you wish, pause, rewind the video, go back, watch some more. But I'm going to go ahead and I'm going to start some guided practice with you. Looking at our directions, find the distance between each pair of points whose coordinates are given. We do need to round to the nearest, and I think I changed the units to the hundredths. Now, if you look at number one was literally how far away are these? So number one isn't too bad because you can just count. But if you look at number 2, you can't just count because it's a diagonal. It's not vertical, it's not horizontal. And therefore, what we will do is we're going to draw a right triangle. And I'm going to go ahead and draw mine underneath. And now when I notice it, being a right triangle with one missing part, I can use the Pythagorean theorem. And the missing part here is the hypotenuse. It is the longest edge. It is the edge opposite of that right angle. Using the Pythagorean theorem, I'm going to find the length of both legs. So if I look at the red leg, 1, 2, 1, and 2, and 3, so that's going to be 3. And if I look at the blue leg and just count off 1, and 2, and 3, and 4, and 5. And now this looks like all the other times that we've used the Pythagorean theorem. 3 squared plus 5 squared, 3 squared is 9, 5 squared is 25. Put them together, 34. Oh, Mr. Callan, don't forget to make your estimate. Make your estimate, make your estimate. So if I see a leg of 3 and another leg of 5, I'm thinking 6, 7, 8, somewhere in there. Remember, we don't want to know what c squared is. So let's get rid of the square power with the square root. Because square powers and square roots cancel out, that leaves me with c is about 5 and 8300. Say that's pretty close to 7 that I wrote. Notice it does not say miles, it does not say feet, so we're going to write units. Notice we don't write square units, we don't write cubic units. This is a one-dimensional length, and of course you don't have to write that one if you don't want to. Now if you wish, you can pause and do number 3, but I'm going to go on to number 8. Number 8, people start to get a little panicky. Mr. Callan, there's nothing graphed. Okay, so what do you think we do? We're going to graph each pair. Then we're going to find the distance rounding to the nearest hundredth. So if I look at -4, -3, -4 goes to the left, -3 down, and so we have a point in the third quadrant. If I look at 2, 1, positive 2, positive 1, that's going to go 2 to the right and 1 up, and that's going to be in the first quadrant. Now we're asked to find the distance between those points, but I can't do that because it's a diagonal. Well, I can't do that until I draw a right triangle and use the Pythagorean theorem. Noticing that the hypotenuse is the missing part. Meanwhile, if I count the red leg, 1, 2, 3, 4, and the blue leg, 1, 2, 3, 4, 5, and 6. Sorry, that dot is so big, but it would be 6 units. Don't forget your estimate, Mr. Callan. So 4, 6, 7, 8. Last time I guessed too much, but I think it should be close to 8. Let's find out. 4 squared, 16, 6 squared, 36. Put them together, 52. Let's get rid of that square power with the square root because a square power and a square root cancel out. 7 times 7 is 49, so it's going to be a little bit bigger. Hey, that's not bad. That's pretty close to 8 units. So when in doubt, you are welcome to graph out the 2 points and then draw your right triangle. Now, I had a great question from students in the past. The question was, Mr. Callan, what if I don't draw the right triangle above? Can I draw it below? Can I do it on the other side that you did? And so I said, well, you tell me. Take a look at your right triangle. What would be that vertical length? 1, 2, 3, 4. What would be your horizontal distance? 1, 2, 3, 4, 5, and 6. And so they very quickly notice that they still have a right triangle. They still have 2 legs that are 4 and 6, and therefore the triangles are congruent. In other words, ladies and gents, you may draw your triangle above or below and have the exact same legs. Either way will lead you to the proper hypotenuse. Now, folks, numbers, well, the bottom of that first page, whatever the numbers are, it says attempt to use that Pythagorean theorem. So I'm going to push you on this. This might not be something that's on the quiz, or if it is on the quiz, maybe it's more of a challenge problem, but I would argue that you should at least try it. So a little disappearing ink here. Let's see here what we're going to substitute in. If I line up the points 5, -3, and 9, 1, I can see that the second x value is 9 and the first x value is 5. So I'm going to subtract 9 minus 5. I can further see that the second y value is 1 and the first y value is -3. Now be careful because we are subtracting a -3. And of course, anytime you subtract a negative, you really are increasing, right? So weirdly enough, 9 minus 5 is 4 and 1 minus a -3 is 4. That almost never happens, folks, but it did here. So 4 squared is 16 plus another 16 is 32. The square root of 32 is 5 and 66 units. Now, I did leave the graph here, but can I just point out that while 5, -3 fits nicely, 9, 1 does not. Unless, of course, you change the scale, which you're welcome to do. So then 5, -3, and 9, +1 would fit. The only hesitation is it gets a little tougher to figure out what the 2 legs are. And imagine if that weren't 9. Imagine if it were 79. Imagine if that y coordinate wasn't 1, it was 201. You can change the scale to 10s, 20s, 50s, but it's going to be pretty hard to figure out how far up and down that you go. So there are certain times when using the distance formula would be hugely helpful. Can I ask you, please, I would highly recommend that you write this down if you have not done that already. And then if you want, you can pause and try the other two while I go to the backside. Backside says use the Pythagorean theorem to find the distance between given locations. Each unit on the coordinate plane is 150 feet in real life. Round it to the nearest foot. Nearest foot, oh, that's interesting. Nearest foot. Okay, more on that in a minute. Let's go ahead and do number 13. We're going to find the distance from the school to the fire station. Now, if I notice that the school is right there, the fire station, I'm going to get my ruler out, get my ID, any kind of straight edge. I'm going to draw that. And I'm going to now draw a right triangle Shucks, sorry about that. There it is. So being a right triangle, we can write a squared plus b squared equals c squared. By the way, I'm going to do two different methods. You might want to put your pencil down, watch the video, and then pause and write which method you like. Now, I need you to be careful because looking at the scale is not going by ones. The scale is going by twos. So be careful there. So if I started at 3, if I start at -4 and I go 1, 2, 3 units to the left, that means the first leg is going to be +3. If I start at -4 and I go down, there's 1, there's 2, there's 3, there's 4. So my other leg is going to be 4. The rest of this is going to look familiar. 3 squared is 9, 4 squared is 16. Put them together is 25. Take the square root. Wait a second. You can't say that's 5 units away. Oh. Each one of those 5 units is 150 feet. Now, I promised you a second method, and so allow me to show you, please. I quite understand if a student would prefer to change it to feet at the very end. However, some students would argue, Mr. Callen, why don't I just change it to feet right from the beginning? See, if each of those 3 units was 150 feet, then you could claim that one of the legs is 450. If each of those 4 units was 150 feet, then you could claim that the other leg was 600. Now at this point, a calculator is quite all right. So if I take 450 squared plus 600 squared, it will be 562,500. Now remember, that's the square of c. So let's take the square root of both sides. I'm not even going to bother with the plus or minus. And would you look at that? Square root of 562,500 is still 750. Now, quite honestly, I like the first method a little better, but I need to warn you of something. Let's say that it wasn't exactly 5 feet. Let's say instead of 5, it was, well, let's do the square root of 24 instead of square root of 25, right? So this ends up being 4.8989799486 ... And I want to multiply that by 150. I'm going to go ahead and press answer times 150. So this would be a good answer, 734.8 something something, actually closer to 735 feet. However, I have seen far too many students round right off the bat to the nearest hundredth. And you're going to say, Mr. Callen, what does it matter? Well, check this out. If I multiply 4 and 90 hundredths times 150, poor example. All right, that didn't work so well because it ended up being exactly the same. So I'm going to do something different. Let's go with the square root of 107. So this ends up being 10.3440843 ... Multiply that by 150. 1551.6, which would be 1552, okay? Now, let's say you rounded first. 10 and 3400 times 150 is this. Notice how they're just slightly off. Now you might say, Mr. Callen, these digits are so small they're insignificant. But if you take 150 of them, or if the scale wasn't 150, the scale was 2000, those little bitty digits will matter. So here's my point. If you choose the first method, do not round. Keep that whole answer on your computer and press answer times 150. And then you will get as precise as that calculator can get. If you round, you might end up being just a little bit off. On the other hand, if you do option 2, There will never be a problem because you will only be rounding at the very end. All right, so that took a little longer than I was hoping, but I did want to show you how those little bitty digits can be significant in the end. Whatever the assignment number is, folks, continue on, do well, bring some questions that you got to class, and let's grow. See you.